1 minute. हाँ, ठीक है. Let us take a few more examples. Yes. So in this new numerical, it is mentioned that a uniform bar AB, which is 10 meter long, weighing 280 Newton, is hinged at point B and rests upon 400 Newton block at point A, as shown in figure. If the coefficient of friction is 0.4 at all the contact surfaces, find the horizontal force capital P required to start moving the 400 Newton block. So this is the figure associated to this numerical. This is that block which is of 400 Newton. It is kept on the horizontal surface. Certain force P is applied, and this is that bar. And it is hinged at other point B. So over here, there is a hinge. This is point A. Okay. So what you are supposed to identify? You are supposed to identify the value of P in order to make this block just move. Okay. So this is a rough surface. This block, which is of 400 Newton, this is in contact with two rigid bodies, as you can see over here. First is this horizontal surface, and second one is point A. Okay. Few more information related to the slope of this bar is given. This is 4 horizontal, 3 vertical, and this is 10 meter long. The self weight of the bar is 280 Newton, I suppose. Yes, it is 280 Newton. Self weight is 280 Newton. Okay. What is the natural tendency of this block to move? In which direction it will try to move? With the help of this force P, it will move in the right direction. Okay. So when we talk about the free body diagram for block for 400 Newton, so we will be representing all the forces which are acting on this. So what I will do, I will draw the free body diagram of this. Okay. In this free body diagram, you will have to represent the resistance which is offered by the rough surfaces. Coefficient of friction is given to be 0.4 for all the surfaces. Okay, so this mu s value is 0.4. This is given. Now just let me know. This is force P. The normal reaction will be there. Let me call this to be, let's say, Na. Okay. Which direction should be the arrow for the frictional resistance for this block at this point? Like, opposite to P. Okay. This is pertaining to this horizontal surface. As you can see from this figure, this block is also connected at point A with the help of this bar. So certainly there will be two reaction forces. One will be the normal reaction force and another one will be the horizontal or the frictional resistance. So can you let me know what will be the direction at this point A for frictional resistance? Normal resistance, normal reaction, so that is okay. That will be this. But what about frictional resistance? Towards? Right. Okay. Why you feel so? At this point, I am saying I am saying at this point, see what I am doing, I am separating this block and I am separating the bar. Like this. Okay. So you know the normal reaction shall be equal and opposite if I draw the free body diagram. Okay, so what you can do is you call this to be NR, normal reaction, and since this point is point A, you call this as NA. Right? So if I am concerned about the free body diagram of this block of 400 Newton, in this case, we have drawn the frictional resistance for horizontal surface. What will be the frictional resistance at point A? So someone told me that it will be on the right side. Is this okay? Will it be true? Now just try to understand. This complete block is moving in the right direction. Okay? We are drawing the free body diagram of this block. Right? We are concerned only about this block. So whatever surface this block is connected with, whatever reactions will be developed, those will be same throughout, isn't it? So whatever reaction forces, say for example, the frictional resistance is developed at the horizontal surface at this location, it will be same over here also. Okay? So the direction of frictional resistance will be like this. If it is on the left hand side at point A on block of 400 Newton, then it will be transferred equal and opposite on this bar AB. Okay? Yes. See, what we are doing? We are drawing the free body diagram of this block. Let me call this to be block A, right? And with the help of this P, which direction it is moving? In the right direction, towards right. So whatever this block is in contact with, whatever rigid bodies may be there. It may be the horizontal surface or whatever else rigid body is there. So here it is this bar. Okay. So if it is moving in the right direction, we are supposed to represent all the forces pertaining to that block only. Okay. And if you can observe over here, since it is moving in the right direction, the forces, resistance forces which will be there will be equal and opposite, rather in the opposite direction. Okay. So whatever may be the surface, it may be this surface or this surface, the frictional resistance which will be offered by this block will be opposite to the force exerted, right? And similarly, on the other rigid body, this will be transferred in the equal and opposite order. So likewise, let me call this to be 0.4 times NR, and over here it will be 0.4 times NA. Here also this value shall be 0.4 times Na. Only the difference it will be in opposite direction. Magnitudes are same. Okay? At point B, since it is a hinge, you will expect two reaction forces. Now over here, as you can see the position of this hinge, how it is like this. So one reaction will be in this order, in this manner, and another may be like this. Correct? So let me assume the direction of this reaction force at point B to be like this. So let me consider this to be RB horizontal, and let me consider this to be RB vertical. Initially, I don't know what will be the direction of this RBH. So I will be assuming it to be likewise. One more information, that is sulfate is given, that is 2 0.80 Newton. This is 5 meter, 5 meter, since it is completely 10 meter length. Okay? Now what you do? Yes. Okay, sorry. So self weight of block over here is 400 Newton. That is correct. Anything else? Is this okay now? That is correct observation. Free body diagram should consist of all the forces. Right. So we have completed this. Can we calculate this angle with the help of this information? This is 4 horizontal, 3 vertical. So can you please identify this angle so that our calculation will become easy? So 36.87 degree. Right. So let us start with, let us try to identify the unknown forces. Okay, if I consider the free body diagram of this block, we will observe that there are 3 unknowns. 1, 2, 3. Isn't it? 3 unknowns. And over here, there are again 1, 2, 3 unknowns. But over here, if I apply the moment equation, in that case, I can find out one of the unknown parameters, that is your NA value, which I am interested with. So you consider the free body diagram of bar AB. So apply equations of equilibrium and take moment. Directly you can take moment. You take moment about, let's say B. Moment about point B equal to 0. So I will be writing down the equation. You please verify whether I am writing it correct or wrong. Okay. So Na will be Na into that value shall be 10 cos 36.87, rotating about point B in the clockwise direction. Then this will rotate in the anti-clockwise direction, 0.4 times Na into, over here it shall be 10 sine 36.87. I will write down over here now. Another force is 280 Newton. Again, it is moving in the anti-clockwise direction. So minus 280 into this horizontal component, rather distance, it will be 5 cos of 36.87. Any other force? Equate it to 0. From here, I can get the value of Na. So there is no need of writing down the equations fx equal to 0, fy equal to 0. With the help of this very equation, you will get the Na value. What value of Na do we get? I am getting this value to be 200 Newton. You can verify this. Okay. Then you consider the free body diagram of block. You know Na you have already evaluated over here. Now over here you can make use of summation of forces in x direction equal to 0 equation, and from that you will get P minus 0.4 times Na minus 0.4 times Nr equal to 0. And from here you won't get the p value because we don't know Nr value. So in order to calculate Nr value, you can make use of this equation, that is minus Na minus 400 plus Nr equal to 0. So Nr 600, and once you say Nr value we have calculated and Na already you have calculated, then you can easily calculate this P value. It comes out to be 320 Newton. ठीक है, this is fine. Right. You can take up next numerical. Yeah. See, there is a plank, wooden plank you can say, which is resting on such surface, inclined surface and one horizontal surface. This is a wooden plank. The length of this wooden plank is mentioned as 12 meter. It is 12 meter long. Okay. And this is the horizontal surface. This is inclined surface. The inclination is 60 degree. These are rough surfaces. This is horizontal force, capital T. This is vertical force, capital P. The distance is 4 meter. This is 5 meter, 3 meter. This is point A, point B, or this is plank AB, you can say. Now, what is given? This plank is of negligible weight and is supported and carries the horizontal and vertical loads as shown. Coefficient of friction of all the surface is 0.3. If capital T is 300 Newton, determine the value of capital P to start the motion downwards. To start the motion downwards. So in this numerical it is given that this wooden plank is going to move in the downward direction. Okay? So let me know what should be the direction of frictional resistance at point B. Okay, upward. And what about point A? Towards left. Towards left. Towards right. It will be towards right because towards right. The movement, I think you told me about the movement. It is actually the resistance will be now in the right direction. Okay. So this is point A. This will be normal reaction at point A and this will be normal reaction at point B. Bar is of negligible weight. So you draw the free body diagram. Okay, plank. This is wooden plank, you can say. And at this location, these are the forces. And this is an 0.3 times NA, and the B, and this will be like this. 0.3 times NB. Yeah. This is capital T, which is given to be 300 Newton. This is capital P. This is 4 meter, 5 P meter. Capital. 60 degree. So resistance, external resistance. Right. Now, with respect to this axis, X and Y, you can resolve this into components. So this will be, just correct me if I'm wrong. This will be 0.3 MB cos of 60 and 0.3 MB sine 60. Am I right? And this will be NB cos 30. This will be NB sine 30. Please check. So if this is okay, you have equations of equilibrium with you. Okay? Fx, Fy, and moment equation. All these things will be required in order to calculate the unknown force P. Summation of forces in x direction equal to 0. 0.3 Na positive plus 0.3 Nb cos 60, this is again positive, minus Nb cos 30 और कुछ है horizontal direction में plus 300, this one. Okay, so 1, 2, 3, 4, these forces I have incorporated, equated to 0. From here, I will get equation in the form of Na plus Nb, Na and B. Okay, you can expand that equation or modify or solve that equation. Then summation of forces in y direction, positive Na minus P, then plus 0.3 Nb sine 60, which is upwards, plus Nb sine 30, again this is upward, and anything else? So how many forces? 1, 2, 3, 4. Equated to 0. Uh, the self weight of this plank is 0. That's why we have not included any value associated to the weight of the bar. So from here again we can get, but over here this is unknown parameter, isn't it? So we will get some equation from here, equation from here, and these two equations will be insufficient to solve and to get the value for P. So in that case, we need to take moment value. So you can take moment about any of the points. Let's say summation of moment about point B equal to 0. That will be easy. I mean, uh, we will be eliminating all these inclined forces. So what we have is these horizontal and vertical forces. So you equate, what do we have over here? Okay. So this complete distance will be how much? 9 plus 3, 12 meter. 12 meter. So 0.3 times Na. 0.3 times Na. This is going to move in the anti-clockwise direction. This will be 12 sine. What will be this angle? Can anyone tell me what should be the value of this angle? Actually, it is given. This angle is given as 36.9. This angle is given 36.9. Okay, so this will now become 36.9. Okay. So it is moving in the anti-clockwise direction, like this, negative. This will rotate about point B in the clockwise direction. So Na into 12 cos of 36.9 clockwise. This plus, now this is going to rotate about point B in the anti-clockwise direction, minus 300 into, what will be this distance? Perpendicular distance? This much? 8 cos 36.9. This, again it is going to rotate in the anti-clockwise direction. P, this my distance shall be 3 cos 36.9. Anything else? We have covered all the forces. I suppose 1, 2, 3, 4. 1, 2, 3, 4 equal to 0. This is equation number 3. You solve all these 3 equations and get the value for P. So you can take this activity as your homework, you can say. And you also identify the value of Na value and Nb value. Okay? So you can solve this. Next. Right. So we will see next part, which is of waging action. Wage. These wages are nothing but huge blocks, and with the help of these huge blocks, another huge load is what you can say carried, and the load carrying mechanism is through frictional resistance. For example, this is the case. This is a heavy weight of such shape, right? And this heavy weight has to be moved from one position to another. So how it is moved? So you can say, you can take the advantage of this shape, and you can make use of another blocks like this. Okay. Something of this sort. These are another blocks. So it is not necessary that it will be touching. It may be like this also. These are the two blocks, and on these two blocks you can say this this block of weight, heavy weight you can consider, of tons, that is resting. So if you apply force in this direction, what will happen? These two blocks will try to move in this direction. It will try to get compressed, compression side sort of thing. And by the virtue of this, you will see there is a movement in this heavy block. The movement actually is carried out or conducted with the help of frictional resistance, because the surface of this weight and surface of these two blocks, they are in contact with each other, and they are not smooth surfaces, they are rough surfaces. Okay? So this is known as the wedging action, and we will be solving few numerical associated to this wedging effect. So we will take up one example which is pertaining to this figure itself. There may be certain more different types of wedging actions which we will come across, and we will be solving those. Okay? So over here we will make use of the angle of friction, then the coefficient of friction. So let us try to solve these. So let me consider these are the two forces equal magnitude P. This angle, this is complete angle you can say. This is of 15 degree, 1.5. Right? This weight is of 1000 Newton. This is given. Moreover, these weights, they are resting on ground, a rough surface, right? So in this numerical, what it suggests, what force capital P must be applied to the weightless wedges. So compared to this weight, they are very small weighted, or you can consider them to be weightless. They are weightless wedges shown in figure, to start them under the 1000 Newton block. The angle of friction for all contact surface is 10 degree. Phi s value is 10 degree. This is what is given. So the complete uh, solution of this numerical, it rests on free body diagram. Okay. So over here you can try to understand. First of all, we will try to understand the free body diagram. So we will try to see what will be the effect by the virtue of this P and P, how these blocks will move, that we know. These two will move in the compressed direction. Okay, and because of that, what will be the effect on all the three blocks? These wedges and this 1000 Newton block, that we will try to understand. So what I have done, I have separated all the three blocks. Okay. Now I will be representing the forces. This capital P. This is of 1000 Newton. Correct? So now we can understand, since this block is moving in the right direction, we will represent all the forces associated to this block itself. So last in the previous numerical, what we saw, that for this block, if it is moving in the right direction, whatever may be, whatever rigid body it may be in contact with, that will create frictional resistance, but with respect to this P itself. So therefore, at this point, that is at the earth surface, the resistance shall be in this manner. And since this block, weightless block, is in contact with this 1000 Newton block, this will again be in this direction. Okay. Then there will be normal reaction as usual. There will be normal reaction like this. Similarly, over here, what do you anticipate? How will be the direction of resistance? It will be like this over here, and it will be like this. Correct? Opposite to this force. Similarly, this will be the normal reaction. Normal reaction. Okay. So let me see. Mu s value is not given, right? So what you can say is mu s. Let me say nr. Let me consider this to be point A, this to be point B, and likewise you can say C and D. Okay, so झंझट ही खत्म. And C, this will be NA, this will be what it will be NB, and similarly this is mu s times NC, this is mu s times ND, this is mu s times NB, this is mu s times NA. Okay, so this is the free body diagram for these wedges, you can say wedges. Similarly, you are supposed to show or represent the forces which will be transferred equal and opposite on this block. So since the direction of the frictional resistance is in the left direction, on the block it will be in the right direction, like this. Magnitude shall be same, mu s times Na, and similarly over here it will be in the opposite direction to this. Magnitude again it will be mu s times Nb. Is this okay? Is this understood? So what you can do is, since you can simplify your problem, and what you can say is, this is the resultant. Okay, let's say RC, and we have seen earlier in our discussion that the angle which is made by this normal reaction and this resultant, it is your phi s value. Likewise, you are supposed to identify the this normal reaction and the resultant. This will be phi s. So what I am doing, I am replacing the two components with the help of only one resultant value and the angle, so that we can make use of this phi s value in a very simple manner. Similarly, over here, the value shall be like this, and it will be like this. So I will be drawing the bigger scale so that you will understand how is this R values. Okay, so let me draw this. Let me talk about this wedge. From this wedge, this is capital P. Okay, we will agree. This will be RC phi S. Okay, this is one. Above that, it will be like this, R A. Is this okay? But over here, what do you observe is this one minute. Actually, this Na is inclined, okay, and this frictional resistance is like this, correct? But the axis, vertical axis is this. So over here, the resultant will be acting in this manner. Let me consider this to be RA. This angle will be phi s, but this angle is different. This angle is nothing but this angle. If you see the geometry, these two angles will be same. In our numerical, it is given as 15 degree. So this will be again 1,5. Whereas phi s value is mentioned as 10 degree. Okay? We are interested in finding out these R values. This is phi s. Since this normal reaction is perfectly vertical, therefore the phi s value will be directly 10 degree. Got me? Is this okay? And on the same line, the free body diagram for this block, second block, okay, for this block, it shall be, now just we need to be careful, since this NB value is inclined, okay, so ये है आपका NB and this is frictional resistance, you can say. Over here, this will be the resultant value, correct? This will be RB, and this will become the angle, which is this angle, 15 degree, 1,5. And this remaining angle will be phi s, that is 10 degree. Okay, over here at this location, this will be your simply RD value, and this is your phi s value or 10 degree, whatever. Okay. So once we know what are the reaction forces on these wedges, then we can transfer equal and opposite parameter on this block. So let me draw that. So as we know over here, this is like this. Okay. Over here, this will be your vertical axis you can consider. And with reference to this vertical axis, now how will be the resultant value? So I can extend this over here. This is the frictional resistance. This is vertical axis, and similarly over here, this is the frictional resistance. This is vertical axis. So you know that this angle is 15 degree. This again is 15 degree. Remaining is the resultant. This will be the resultant. This will be resultant. These are your Na and Nb values. Na, Nb. So the angle which is made by this resultant with respect to the normal reaction, that will be your angle of friction, which is 10 degree. And over here it will be 10 degree. This is Ra, Rb. Got it? So this completes the free body diagram as far as the waging action is considered. Okay, have you understood this thing? So we will be solving this numerical pertaining to all the resultant or yes, resultant forces. And let us see what will be the value of the unknown value P. Okay? So we will see the complete solution of this numerical in the next class. So I will stop over here. Thank you.
Thank you, sir.
Yes.
Thank you, sir.